Don't look at me, it's your presentation. You present it? That's okay. PC then? PC1 or what right now?
It should be.
Yeah. So, I guess the next speaker doesn't need to be introduced at all. Most of you probably saw him at another conference, on a workshop or something, or wrote him on the email list or directly, waiting for some great answers. So, András is going to talk a bit more about plans for the next OMNeT release, and afterwards we have another talk about a specific new feature.
So the timing of this workshop was quite convenient, that we are quite in the middle of the development of next OMNeT version. So in next minutes I will give you some overview of the current snapshot of development, and maybe I can also collect some feedback on your preferences and what you would like to see and what you'd like to change. Okay. So OMNeT 5.0 was released in April, which is not a very long time ago. We worked a lot. It was in preparation for like more than 3 years, and it contains a lot of new APIs, 2D graphics, 3D graphics, a new logging API, new graphical runtime, and so on. But we also had to restrain ourselves, and so in order to be able to ship OMNeT, we had to cut some features. We didn't upgrade to the latest Eclipse version. We didn't upgrade the Windows toolset, and we had some more ideas that we could not complete. So this slide contains contents of the presentation. So one thing we are going to do in the 5.1 version is to upgrade our dependencies. So we upgrade to the new Eclipse version. A new CDT probably affects most people only via CDT upgrade. And we also updated our Windows toolchain. The big change is that we go from 32-bit to 64-bit. We decided that dropping support for 32-bit Windows toolchain is tolerable for the community, and we could not venture like shipping both versions because it would double the size of the download, and it's already quite big. Okay, we are also making Qt 5 mandatory. We checked all the dependencies on all Linux versions that we support. Qt 5 is the default now, and for Windows and Mac, we ourselves ship the Qt libraries so we can safely do that. And they also, you can see here all the required versions of OpenSceneGraph and OSG Earth. So our next big change is on the build system, how we build OMNeT and how we build the models. The big motivation was that every time one builds the INET framework, there's a dialogue saying collecting includes. Please raise your hands if you were disturbed by this, if you've seen this. Yes, we're also annoyed by this. So we look more deeply into generating dependencies for C++ projects, and now we have switched to using compiler-generated dependencies. So the dependencies are basically makefile fragments. They are put into the output directory. They are .md files. And they are basically created as a side effect of compilation. When you do make clean, these files are deleted again. So if you change some file, it will be recompiled, due to the dependencies. At the same time, its dependencies are also refreshed. So dependencies will be up to date all the time, and one doesn't need to do make depend manually anymore. And as a side effect, the code inside the IDE has also significantly been simplified. So it's also less work for us. Okay, at the same time, we also did more simplifications. We tried the deep includes support. For earlier INET versions, all directories in the source tree were automatically added to the include path. And we found that this has caused some troubles for bigger projects, and especially if you have another project which builds on top of INET, then there could be some confusion of if there are include files that have the same name. So we are dropping this deep includes support. Okay, we have also improved the support for project features. For those of us who don't know, project feature is a great feature to cut compilation time of INET. Basically, that was the main purpose, to force modularity and to cut compilation times. One problem before was that this defines that tell the compiler whether some feature is enabled or not. It was passed to the compiler via command line, and we have switched to putting these defines into a generated header file. And this has two advantages. One advantage is that the source code editor inside the IDE now knows which features are enabled and which features are not enabled, so the if-left blocks are grayed out correctly. And the second advantage is that now derived projects, so projects that build upon the INET project, they can access the feature enabled state more easily. We've spent a lot of time working on QTemp, which is a replacement of the TKM. And during the last month, this new user interface has reached maturity. So we are making it the default user interface for the next version. TKM can still be used, can still be activated, and it will be maintained, but we will not put any active effort into porting new features into TKM. So we'll phase it out gradually. And if there is some kind of consensus that we don't need that anymore, then we drop it from OMNeT. In QTemp, in addition to a lot of bug fixes, there were also some new features, like we made the simulation time display more readable by displaying units, and we put in a lot of organization into context menus, put in new context menu items, and did some other usability issues, fixes. Okay, we improved the Canvas API. Figures can now have tooltips. Second one is figures can have an associated object. So for example, if you have a figure that shows a car, for example, and it represents basically a car module in the model. Now, if you click on the figure, then it will show the car module in the inspector. This can be quite useful in a lot of cases. So, for example, if we show a packet transmission as a growing circle or growing bubble, if you click at the bubble, we can show the packet, not the figure, in the inspector. So it's easier to look at things. Okay, Z-index is a way to specify the stacking order of figures, and it has been available as a parse time property, but now it's a proper figure property, and this makes the organizing figures and the stacking order of figures a lot simpler in some cases. We have also added an option for text halo, which is like a pale outline of text items, and this is useful when several text items are placed close to each other, and that makes them more readable. This can be useful sometimes. Okay, we have also added support for measuring text figures and measuring images. This has not been available in the 5.0 version because so far the data flow was one directional. The user interface could read data from the simulation, but the simulation could not read graphically related things from the user interface, because one could run the simulation under the command line environment, stuff like that, and then there is no rendering of text times. So that was the primary reason. And now we have introduced this, so it's possible to measure text items. Okay, we introduce self-refreshing figures. So in the 5.0 versions, modules can refresh their appearance, the canvas. But in certain situations, it's also useful if figures can refresh themselves. For example, if a figure is showing a gauge or a meter or something like that, it can refresh itself when the data changes on demand. Okay, we implemented these features in QTemp, so the new features were not implemented in TKM. We added more tests to the canvas. So the simulation kernel has not seen really deep changes. Some method renaming and some organizational change. So the code which parsed statistics was so far part of the user interface library, and now we put it into the simulation kernel. And this was necessary for some feature that I will talk about later. And we made more things inspectable also in QTemp. For example, now at runtime you can look at the results that are being recorded from statistics, and you can examine like XML valued module parameters, stuff like that. Nothing really big, but they can be handy sometimes. Yeah. In the version 5.0, we have introduced the Canvas API to the drawing API, but refreshing of the display was still tied to events. So the display was only updated right before and right after an event, and this made it impossible to have smooth animations, or actually one could only have smooth animations when by introducing artificial events like these timer events. At each timer event, we would redraw the display. And we have a proof of concept implementation for doing better, for support for better animations, smooth animations. We will have a presentation about this. Okay, we had a panel discussion about simulation campaigns. So we made, in relation to Antonio's talk, we made some changes. And this affects basically managing the simulation runs and improving the state of result analysis. So previously, one could only select runs for execution by specifying the run numbers, run number ranges, and we have extended this, and now you can specify values, specify a run filter, basically, and select a set of runs for execution by specifying values for the iteration variables. And we have also added some options to query simulation runs. The -q numRuns option tells you how many simulation runs there are in a configuration, and then you can query what they are, what are the values of the iteration runs. With run details, you get more information about this. You also get the configuration entries in the INI file, which contain iteration variables. So it's easier to test what simulation runs a simulation study generates or a configuration generates, and it's easier to test the run filter conditions as well. Okay, we also talked about this, that the default result file naming contained the run number, which was inconvenient in many places, and now we changed the default to using iteration variables. This has also been a request that the repetition counter used to be the innermost loop. So when you execute all runs of a configuration, then it would take a iteration variable configuration and then do all 10 repetitions or whatever number of repetitions you want. And this basically sometimes good, sometimes bad, but it's usually rather bad. So for now we changed it, the repetition counter to be outermost loop, and we are planning on making basic nesting order configurable. Something connected to result analysis. We have improved the CSV export in Scave tool. Until now, the generated CSV file did not include the iteration variables, so we put it in, and this makes the generated CSV files more self-describing and easier to analyze. We'll see examples for this in the next presentation from Rudolf. We have also done steps to explore using SQLite as a result file format. We'll also talk more about this. And we have some long-term plans to improve the usability of the analysis tool to make it more convenient to explore the simulation results, to have a quick glance at the simulation results. And we also want the analysis tool to aid the user going to scripted result analysis. For example, on the click of a button, we could generate a Python script that creates the chart that the user is seeing. So one can copy the Python script and start from there. One doesn't need to start from scratch when doing analysis. Oops. Yes, and we have a small present. We have a snapshot of the development, and Rudolf has some USB sticks, so you can try it. Thank you.
Well, let's give a big hand to András. We still have time for some quick comments, questions about the new features, any ideas for further improvement. They're going to be here all day, so whenever you have some further ideas to improve something.
Yes.
Can you give us a little bit more details about the -r option that you were talking about?
The run filter option? Mm-hmm. Yes. So basically, this is like an expression which is built out of wildcard expressions. So basically, you have the iteration variables string, and you can match against that simply. So this selects the runs which contains this substring. This is the basic use.
In the iteration variable.
Yes, iteration variables. And the second form is that you can form Boolean expressions with and then or for the individual iteration variables. So this will select the run where the value of mean is 4.3 and the number of hosts is between 20 and 20.
The same way as the result analysis tool.
Yes, it's the same filter that the escape tool uses. Yes.
Additional question?
Yes. Since I think of version 3 or 4, my personal impression is that the core of OMNeT plus the simulator is quite mature. So it's most of the improvement and the new additional features are focused on the user interface and interface with external tools. But could you please comment on the, for example, discrete event list is, if I remember correctly, maybe 10 or 20 years ago, lots of researchers focus on using heap, list, whatever, to speed up the event dispatching from the future one. Have you done any research or improvement or any plan for improving this really core of the simulation, not these additional features with the external interface?
Yeah. Yes, the future event list has been made configurable, so replaceable in the 5.0 version. So before it was hard-coded heap, binary heap data structure, and now it's possible to replace it with your own data structure. And I'm aware that there are several other data structures that are used as well, like skip lists and various kind of balanced tree data structures and others. Simple lists, for example, can also be used in some cases. And I know about a study where they evaluated these data structures with respect to various loads and to the relative cost of floating point operations, because we have one essential operation during the operation of these future events is the comparison of simulation times. And so it's an important part of the CPU load. And they have concluded that in specialized workloads, there are other data structures which can be quite useful, but there is one, but the binary heap is still the data structure which is the most reliable and delivers the most consistent results for a wide range of workloads. And for OMNeT, basically, we have to be prepared for a while for really all kinds of workloads.
So that means, for example, using some very fancy new data structure to replace the currently existing OMNeT plus event list, that looks like, or you haven't been able to see any fundamental improvements. Whenever you replace the current one with any new data structure, then you haven't been able to see any fundamental improvement in
We haven't replicated the study, but I guess we would not be able to see huge improvements. So based on that study, we didn't see this option worthwhile to investigate. Or, there's always a list of priorities, and this was always on the list, but not that high enough on the list to be actually done.
Additionally, OMNeT has some optimizations for specific things, like a lot of times you schedule the event for the same simulation time. That is, for example, handled especially in OMNeT. So it's not looking to be new, but rather it's capturing separate list, which is more easy.
simultaneous events on the same time.
Yes, I mean, if you schedule the event for the current simulation time, that doesn't call it the structure is
Yes. And otherwise, the question is still open. So if someone has PhD students looking for for a topic that.
Okay, I guess there are probably 10 or 20 or 30 more questions. We're going to get all those questions tonight or in the next break. Let's give a big thank for András and his talk.